Happy Valentine's Day, everyone. Happy February 14th, one of the days of all year. And if you don't have what the millennials or Gen Zers, I'll let you find it out in the comments, would call a bay this Valentine's Day, then have no fear, because you're going to learn about Bayes' theorem. Get it? Because it's like close to saying bay. But as the title of my video suggests, Bayes' theorem really is bay. So if you already have a bay, just saying that they might have to come in second to Bayes right here. Bayes' theorem. Now, what is Bayes' theorem? Bayes' theorem is a formula that you see in probability and statistics, and it generally deals with conditional probabilities. So I'm going to write here conditional probabilities, which I'll abbreviate as prob. And the way that it's written out, the way that I like to think about it, is in the following form. Let's imagine you have H as your hypothesis and E as your evidence. Okay? Now this is a way, as a scientist, I like to think about Bayes' theorem. The way that we can state it in words is P of H given E. That's what the vertical bar means. It means given. So I'm saying the probability that my hypothesis is true, given that I've seen some evidence, is equal to the probability I would see that evidence given the hypothesis is true, multiplied by the probability that the hypothesis is true in the absence of any evidence whatsoever. This is what is known as a prior. That's sort of what you would give to your credence to the hypothesis being true in the absence of not seeing any data whatsoever. And all of this is divided by the probability of seeing the evidence. Now, you can also expand the denominator here, in a following second. I'm just going to keep writing this out. The probability that you see E, the evidence, is the probability you see the evidence given that the hypothesis is true, times the probability that the hypothesis is true. That's just the numerator. But you also have to consider the probability that you see the evidence given that the hypothesis is not true. And I'm already running out of space here, so I'm just going to cut this, bring it down here, because I feel super high-tech here. I'm going to erase this. I'm going to say E given not H times the probability of not H. So in the language of Bayesian probabilities and statistics, this is known as a posterior. This is what you're trying to calculate. P of E given H is known as a likelihood, as in how likely you are to see the evidence, given that the hypothesis is true, and this is known as the prior, as we mentioned before. So these are all the standard terminologies for Bayes' theorem if you study it in a probability class. Now, instead of just talking about it in words, let's actually apply it. And what better way to apply Bayes' theorem than to figure out if your would-be Bay likes you? So let's come up with a good example here. For example, hypothesis. Let's just say my crush, I really hate using the word bay. Let's use crush. My crush likes me. Aw, isn't that so sweet? That's the hypothesis. My crush likes me. Wouldn't we wish that was just 100% true all the time? Fortunately, I think, as most people know, that's not always the case. Not me, of course. I never figure that out. Now we have to consider the evidence. What's the evidence? So let's go with a very common example that we see in our high-tech, high-speed world these days. Let's say my crush texted me within 2 minutes. 2 minutes! 120 seconds, flat. You DM'd them, you hit them up on Instagram, you hit them up on the Facebook Messenger, you texted them, and within 2 minutes, they got back to you. And now you're thinking to yourself, oh wow, they might actually like me. So, as a good Bayesian, what you do is you formulate this question. First, let's assign the probability that your crush actually likes you. And let's just say, for the sake of argument, that you give it about a 25% chance, right? That's a 1 in 4 chance. So, not likely, but it's not completely ludicrous either. They could perhaps like you, but 3 times out of 4, most likely not. Though I think it does give you some hope. I think this is a reasonable number, right? This is like, okay, this is not entirely crazy, but it's probably not going to happen. You don't want to sell yourself too short, right? Never sell yourself too short. Okay, next, let's think about the probability of seeing the fact that they would text you within 2 minutes, given that they like you. So the hypothesis is true. They like you. What is the probability they would text you back within 2 minutes? I have no idea. But assuming if you liked someone, you'd probably want to respond to them sooner, right? I mean, that's just sort of my way of thinking about it. If you express liking someone in another way, leave it in the comment section below. Let's just say, for example, it's 90%. So 9 out of 10 times they would respond to you within 2 minutes of receiving that nice instant message or DM that you sent them. Now we have to think about the probability that they would respond to you within 2 minutes, but the hypothesis is false. It's not true. They don't actually like you, but they did respond within 2 minutes. So perhaps you just caught them at an opportune time. They were just on their phone and you DM'd them and they just saw, oh, so-and-so messaged me and I'll respond back right now. So what's the probability of that happening? I don't know. Let's just make a number up. Let's think maybe 50-50, right? Maybe if they really liked you or didn't really like you, but maybe they're just a good person. They just want to respond without making you wait for too long. Let's just say it's about 50%, okay? Let's play around with these numbers. We don't really have any hard data or studies to verify this, but if you did have empirical studies that had numbers that you could assign to these values, it might be a better estimate of the probability your crush actually likes you. So anyways, with these 3 numbers, we are ready to calculate what is the probability they like us given they texted us within 2 minutes. So again, we write P of H given E is equal to P of E given H times P of H over P, I'm going to expand this out, P of E given H, right? This is P of E, given that the hypothesis is true, times the hypothesis is true, plus P of E given not H, as in the hypothesis is false, times the probability that the hypothesis is false, P of not H. But P of not H is equal to 1 minus P of H, because essentially the probability of not H plus the probability of H, they either like you or they don't, right? So that has to equal 1 or 100%. There is no in between. So just doing some rearranging here, we can say that the probability of not H, of the hypothesis being false, is just 1 minus the probability that the hypothesis is true. So I'm just going to write it like this. P of H. Okay, great. Now we are ready to plug in some numbers. Plug in those numbers and let all your hopes and dreams be calculated, I guess. I don't know what I was going to say there. So P of E given H, so we're saying the probability that they would text us back that quickly, given the hypothesis was true, is 90%. P of H in general, we said is 1 over 4, 25% chance. We repeat that term on the denominator. But then we have to do this term right here, P of E given not H, which we're going to say is 50%, 5 out over 10. And then we're going to do 1 minus P of H is 1 over 4. Now, if you actually plug all these numbers into your calculator, I will not do that, but you can essentially do this, you're going to get a number of 0.375, which says there's a 37.5% chance your crush actually likes you, given that they texted back within 2 minutes, which is, hey, not bad. Actually, that's actually an improvement. Our prior was 25%. Our posterior is 37.5%. So, hey, with the evidence, our belief should actually go up. We should be encouraged by the fact that they texted us within 2 minutes. Okay. Now, before I end this video, I want to spend more time with you. It's Valentine's Day, and give you even more hope, because perhaps they text you again within 2 minutes. You get another DM within 2 minutes of you sending a message to them. So now we need to, as the Bayesians would call, I am already using the wrong pen here, or I'm using the wrong size. We need to, and the wrong color, but we need to update our priors our priors. So, how do we do that? Well, first off, let me say update our priors in response, I should say, in response to new evidence. I like writing in caps here. Okay, we need to update our priors in response to new evidence. So, one way to do that is to just take our posterior, right? This is the posterior from, let's say, event 1. And now we're going to say this is our new prior. So let's say P of H, I'm going to write here prime, just to say this is sort of a new prior, is equal to 0.375. So this is just now our belief that our crush likes us in the absence of any new evidence. It's going to be 37.5%, which is a 12.5%, I can do math, increase than our previous prior, which was 25% right there. So let's say, for example, we kept the same exact probabilities before, conditional probabilities as before. We're going to use these. Oh, whoa, where'd that come from? I just totally made that huge. We're going to use these same exact prior probabilities. So let's say the new evidence. So new evidence. They text us back within 2 minutes a second time. So this is the new evidence. Our prior for this case is 0.375. And again, we just calculate, let's say P of H given E. Let's say E prime maybe. Maybe I'll write it like this. We saw E and we saw E prime. And this is equal to, I'm going to make a prime here, just say this is new. This again is equal to P of E given H prime times P of H prime. And then we just repeat the calculation down below, right? So like this. Then we just have to do this plus 1 minus P of H prime times P of E given not H prime, right? But we're essentially going to use the same conditional probabilities that we did before, these ones right here. So again, if we assume that this is 9/10 and we assume that this is 5/10 and this is 0.375, that's our new prior. Our new posterior, our updated posterior, or our just new derived posterior, I should say, this is actually going to equal 0.52, just about. Now, again, because we had evidence that supports our hypothesis, we have more belief, we have more credence in our original hypothesis, right? We had a prior that started at about a quarter, and after 2 new pieces of evidence, that is, they DM'd us, they slid into our DMs 2 times in a row. Actually, well, we'd be doing the sliding, I guess. But nevertheless, it's now been doubled, right? So we are now more than twice as sure that they possibly like us, whereas we were sort of like, yeah, not very likely. We're saying it could happen. This could be real, guys. This could be love. Or not. I don't know. Before I continue or end this video, please know that this is not any sort of relationship advice. I am not a dating coach or relationship expert whatsoever. Please don't actually use this in your pursuit of lifelong happiness. I mean, do use Bayes' theorem in your lifelong happiness, but don't use these exact numbers. This is not derived from any sort of empirical study or whatever. But I just wanted to show you the importance and the power of using Bayesian analysis and Bayesian thinking in your life. So, with that, I think I will conclude the video. I hope you have a great Valentine's Day, and stay tuned for more of me and possibly Bayes' theorem.